Welcome, I'm Dominic and this is Software Without Code. Today we'll be using machine learning to predict stock prices, but just a heads up, this is not professional financial advice and is done as a fun experiment to continue my video series on doing AI without code. Don't make any stock purchasing decisions based on the content of this video. I am providing zero financial advice and I am not a financial expert. That being said, the first thing we're going to need to do to predict the stock prices is to get a data set. I actually downloaded an end-of-day pricing data set from a website called Quandl. I put a link to the data set in the description. I manipulated the data set to extract all the pricing data for just one company, Apple. It was a 1.3 gigabyte file when I downloaded it. So I'm not going to cover how to do that in this video, but in future videos I can. Just let me know in a comment below if you want me to. We also will need to add a column to the data set. This column will, if you remember from the last AI video, we did something called classification, and so we're going to be doing the same thing again with a slightly different data set, but we'll be predicting, instead of actually predicting the price, we'll be predicting whether or not the stock will make a return. So it's a much easier problem because when you predict whether a stock will make a return or not, essentially you're predicting 1, price will go up next day, or 0, price will go down next day. Whereas if you had to predict price, you'd be predicting any value of between a large range, and it's a much harder machine learning problem to set up. So now this is the data set on the screen. You can see here this is all Apple from 2010 to present day. Present day being like November 2018, start of November 2018. And now I'm going to add that column I mentioned. So if you don't understand why we're doing this, you probably will in a few minutes if you keep watching this video, but I'm going to make a column called return, and this is what we're trying to predict. So I had a deep philosophical argument with myself of whether or not this counted as doing code. Ultimately though, I decided that Excel formulas do not count as code, at least for the purpose of this video. It's in the spirit of what I'm doing to use Excel, and I don't count it as writing code. If we were doing Visual Basic for Excel, that would be a different story, but we will have to do one if statement to do this. So just to explain what I'm doing here, I'm just, in this return column, I'm just going to put a 1 if the price goes up the next day, the closing price, and it'll be a 0 if the closing price, if it closes lower than the current day. So if that wasn't clear, let's do an example. So this is the first day, 2010, January 4th. We'll take the closing for the next day, subtract the closing for the current day, and then we will check if it is greater than 0. And just to make sure that this is explicit, I'm going to add some brackets or parentheses, and that's all we're doing. So then I'm going to add a comma, and the value if true is 1, and the value if false will be 0. Great. There we go. So you can see here the price went up slightly from $214.01 to $214.38. So we get a 1 just as expected. Now I'm just going to drag this corner all the way down to extend the formula to all the cells in this column. So I'll just take a second because there's quite a few data points. I kind of chose 2010 arbitrarily. I figured sometime after the 2008 recession was probably a good starting point. And yeah, so just if you look here, you'll see it's 1s and 0s, and this is what we will be trying to predict. Now that we've modified our data set, there is an outstanding issue still. This is actually time series data, and if you remember from my last video, I said time series data was a bit tricky to analyze. Essentially, time series data just means that there is an associated time to each row and a natural order of the data points. So in other words, this data point on January 8th, 2010 comes before this data point on January 11th, 2010. So we're going to have to do something called a time series analysis on this data. And in order to do so, we'll open up our machine learning software, the same one we used in the last video. It's called Orange. We're going to open it up with administrator privileges though, because we will be installing a time series add-on. So to do so, you right click on the program in Windows and you click Run as Administrator. I'm not sure what the process is for Mac OS, however, it's probably something similar. And so we're just going to wait for it to load here. It's going to just take a second. Okay, now that it's loaded, I'm going to hit New. After opening it as administrator, we then will go to this Options tab at the top left here and click on Add-ons. It'll take a second to load them all. We'll search for one. Like I said, it's called Time Series. It just immediately starts filtering them as you start typing. So I'm going to click on Time Series, and in this particular video we'll be using this version 0.3.3, and the action will be install. So I'm going to hit OK, and now this dialog will pop up with a progress bar. Now unfortunately the UI has some issues. It doesn't tell you how much progress is left, and I found during my testing of this add-on that it actually took a few minutes to install. So I'm going to skip ahead to the point in the video where it's already installed. Keep in mind that you will just have to sit here and wait until it's finished. I assure you the program's not frozen, and it is installing the Time Series add-on. But if it takes longer than 5 or 10 minutes, you may want to consider restarting and trying again. I haven't had any issues installing it yet, so I'll see you in a few seconds. Welcome back. So the add-on finished installing, and this is the dialog you'll see. It says please restart Orange for changes to take effect. So I'm just going to hit OK. I'm going to close this. I restarted Orange, and now I'm going to create a new project by hitting New, which you should probably be relatively familiar with now if you've seen the previous video. And the first thing you'll notice on the left is that there's now this time series option on the left side menu. And this is how we're going to be doing our time series analysis. And just as a reminder, time series analysis applies to data with a temporal order, or with like a time or a date time associated with each data point. Now we're going to just jump right into this. So first we're going to drag out the file object. We're going to choose our data to be represented, so I'll choose this Apple pricing data, the same data that we modified earlier in this video. And we're going to take a look here at the various inputs and the various inputs and columns for the datasheet. So we're going to ignore most of this just for the purposes of a nice demonstration, but I'm just going to skip all these adjusted close, adjusted volume, adjusted low, adjusted high. In reality, if you were doing this for real, you'd probably want to include these in your analysis, but like I said, we're just going to keep this simple. I just want to show the very basics of time series analysis. And then you'll notice here this return column. This is what we're trying to predict, whether there will be a return or not be a return. So we're going to choose that as our target. And just as a reminder, our target is the class or label we're trying to predict. Class or label being also similar to category being a class or label. Next we'll look here, we got volume, close, low, high, open, all those numeric features. And just again to remind you, a feature is input to the machine learning system. We went over this in the last video, but just in case you haven't seen the last video, it's good to know. We will keep the date for now, and the ticker, which is Apple, it's going to be the same for all the rows, so we're just going to skip it because it's not important. Every data point has the same ticker. So great, let's hit apply and close. So now we're going to go into this time series tab on the left. Just click it to open it, and we're going to use something called a moving transform. Now this moving transform is going to transform our data set, and I'll show you how. If we just double click it, we can add a few transforms. I'm going to kind of add them at random almost, but here you can see you can do like the mean, the sum, the max, the min, etc. Moving averages, both exponential and weighted, harmonic, geometric means, and this does it over a window size. So in other words, fixed window width. Here it's 5. That means it's going to look 5 data points backwards to do this calculation. And you might want to play around with this number. For this video, I think we'll do 10, but that's just to show that it can be changed. I don't know what the optimal number is. Price or return analysis for stock data is a very complicated topic. So let's just choose exponential moving average, weighted moving average. Mean is fine, I suppose. Again, we're almost kind of picking these at random, and variance. It's just more to show that things can be, or that we can do this for different time series transformations. So next we'll do this for the close as well. So we're just going to look at the open and close. We'll choose the weighted moving, or the I meant to click weighted moving average, the exponential moving average, and heck, why not the harmonic mean. So again, I kind of almost selected those at random, but just doing so for the purpose of demonstration of this video. Now let's choose the window size to 10. I'm just almost done. And again, this means it's going to look 10 data points backwards. So it'll calculate the moving average for the previous 10 data points. Sorry, that data point in the previous 9. So now we hit apply. And again, I have issues with the UI because you hit a button and there's not really much feedback to say that it worked. But I have noticed through trial and error that if you hit it and you see a little loading icon like that, it should be fine. But you never know. So now let's take a look at what we did. I'm going to drag out this data table object. This lets us visualize what our row or columns now look like. And you can see if I scroll to the right, now on the left you'll see what we expect: the return, the date, the open, high, low, close, volume, etc. But now we have these transformations. And the cool thing with these transformations, such as the moving averages, is it actually encodes data about the previous 10, or in this case, because the window size is 10, the previous 9 rows of data. So this is a moving average for a window size of 10 data points. And you might wonder, for the first 9, how does it do the point to volume, but I meant to point to moving average. So you might wonder, for the first 9, how does it actually calculate that? Well, my guess is it sticks in 0 for the data points it doesn't have. So for example, on the first data point, it's probably just taking the open itself, and we can confirm that by taking a look. Yeah, so the open's $213.43, and it's showing the moving average as being $213.43. I'm going to hazard a guess and say that they're just sticking in zeros as placeholders for when it's the first 9 data points, or whatever your window size is. If your window size is 5, then it'll be the first 4. I don't know how I feel about that, whether I'd rather exclude the data points altogether or do that, but it's just something to keep in mind. So now that we have that, we might not want to include, I'll go back here for a second, we might not want to include all this information when we're doing our machine learning. For example, we might want to exclude date. I personally don't really care to include like the high and the low. So, because if you'll remember, we're trying to predict the whether the next day's close will close higher or lower than the current day's close. So I'm just going to, for the sake of demonstration, show you how to exclude those columns. So there is a block called Select Columns right here. We drag it out, and this lets us pick exactly which columns we want to include in our analysis. Notice when I opened up the Select Columns dialog that it had volume on the left and the rest of the features or inputs on the right here. The features on the left will be ignored by the machine learning algorithm. They'll be under available variables, and in the features area, these will be what gets passed through. Now I don't know why features is ignored, but I'm going to move it back here, and just again for the purpose of demonstration, I'm going to move the low and the high and they will be ignored. Actually, I'll move date there as well, because we don't want, we want to be able to predict this make our predictions moving forward independent of what the date is. So I'm moving it into the ignored column on the left. And these, just to reiterate, these features or inputs on the right are what will be passed through. So once we're done, we'll close the Select Columns dialog. And we can now, let's move a data table here just to see what we did. Maybe this will help if you're not sure exactly or you're confused. Hopefully this will remedy some of that. So in this data table, we should see like open, close. We should not see high, low, and as expected, it's not there. Our transformations done with the time series or the time series moving transform block are here. But we can actually take this a step further. So if you saw the last video, I mentioned something called pre-processing. I intentionally ignored it last time just to give the most basic possible example of what to do or how to build your first AI system without code. But let's try it. Let's do some pre-processing just to kind of show you what it is. So some machine learning algorithms actually perform better when all the inputs are in a similar range. So what do I mean by that? We'll take a look at this data table. The price, the open price can range from $92 to like $600 just in the first couple rows. And the moving average, the exponential moving average for probably the open, can range, maybe it has a similar range, but let's actually move more to the right to see volume. Volume is a good example. The range of volume is much higher. We're looking at hundreds of thousands to millions of like the range is in the hundreds of thousands to millions, as opposed to the hundreds or maybe thousand for the price values. And so machine learning algorithms tend to perform better when all these inputs are in a similar range, and that range is usually between a 0 to 1. But we're actually going to do something slightly different. So let's connect the select columns to pre-process. So we're going to pre-process the output of the select columns block. Double click on the pre-process block, and I'm just going to close this because when you first open it, what you'll see is empty right side square. It'll say drag items from the list on the left. And there's a lot of pre-processing options, but we're going to do this as simply as possible. We're just going to move this normalize features, and what this does is it centers the values and it scales them. So in other words, centering by the mean means if you take the average, so if the average opening price across the last 8 years for Apple was something like $500, we would subtract this process will subtract $500 from every open price value, and then the scale component means it'll take the standard deviation of all the open prices and divide them by that standard deviation value, and typically this will like decrease the minimum and maximum range values for each of the columns. And let's show you I'll show you what I mean, because I'm just kind of talking, but I think visuals have the best explanation. So let's double click on this data table, which we fed from pre-process, and so now you can see these values are totally in a different range, and for the most part they're actually look to be in a very similar range, maybe between -1 and 1, somewhere in there. It's not impossible for a value to exceed 1 or -1. As you can see here, this is greater than -1 or more negative than -1, and similarly we could have values that are more positive than +1, but it roughly centers them about the same point, and now they're much closer, so the open is in a similar magnitude to the volume, and we'll see in most cases we will see performance improvements from our AI systems. Great, so now we've done all the hard work, and we've added a few steps from last time. We've added 3 steps: the moving transforms, select columns, and pre-process. Let's actually train some AI models and see how they perform. So I'm just going to jump to the model tab. We're going to bring out the same classification AI systems we did last time, and don't worry, you don't need to know what these actually do, how they actually work, because all we care about is how they perform. And I you don't want anyone to get bogged down by the complexity of this, because in reality we're just connecting blocks, and we care about the output, and that this is the whole philosophy of software without code, is we care more about the final project or output than we do about the process to get there. So I've chosen these 5. I think these are the same 5 in the previous video. SVM stands for support vector machine, and KNN stands for K nearest neighbor, if you're curious. And then we'll go into the evaluate tab, and we're going to drag out 2 blocks here, test and score. So this is how we're going to test, score, and rank these AI systems, and the confusion matrix, which is going to give us an idea on how they perform. So let's go ahead and connect each AI system to our test and score block, all 5, and they'll be trained and tested independently. And just one more. It's hard to click these. And then I'll connect test and score to confusion matrix. So now the final step to get this to actually do something is to take the data and feed it to the test and score, and we'll do that by taking the output of the preprocess block and connecting it to test and score. You'll immediately see that it is running a training routine. That was actually really quicker than I expected. And we can just take a look here, and in a future video I might explain what some of these are, like AUC, area under curve, the F1 precision recall scores. It's something that actually helps you interpret and understand the results, but I think that that's best for maybe the next video or a future AI video. Let me know in the comments what you want me to cover in terms of future AI videos. So now let's go into the confusion matrix block. So the confusion matrix block will help us interpret the results. And just as a forewarning, I do not expect these results to be particularly great. And the reason for that is simply, if I had the ability to predict stocks using machine learning, I'd probably be doing that on my own instead of making YouTube videos right now. But and further to that, there probably would need to be more thought put into this and research. I kind of chose the time series transforms in this moving transform pretty much at random. You might see some good results yourself though, just by trying different things. So don't let this discourage you. Just keep that in mind as we move forward. So for KNN, we're looking at the confusion matrix, and I know I explained this in the last video, but we'll just briefly go over it again. So the elements on this forward diagonal, so the 457 and 585 values, those are what the system got correct, and the values in the off diagonal, so the 534 and 494, are what it got wrong. So 1, just as a reminder, 1 is our category, label, or class. That means that the next day's closing value is higher than the current day's closing value, and 0 means that the next day's closing value is lower than the current day's closing value. So in other words, the price will go up is 1 and the price will go down is 0. So on the top row here, 0, this is what the system predicted. So it predicted that the price would go down, it predicted that the price would go up, and on the left, this represents what actually happened. So on the left, we see that the price went down and it predicted that it went down is 457. So this means that this is correct. However, on this one, it predicted the price would go up, but in actuality it went down with 534. So down here we have it predicted they would go up and it actually went up, and then it predicted it would go down and it actually went up. So just looking at these results, it seems like it's basically guessing, because it had got almost as many wrong as correct. We could do more of an analysis to see if it has done better than just guessing, but looking at these results, it's not too promising. Let's move to naive Bayes, and so here we get something a little more interesting. I'm not saying better, it still looks like it's just guessing, but basically we see that the system tends to favor predicting that the price will go up, or that the closing price the next day will go up. So we see that it made more predictions on this side, and correspondingly it got more wrong than the last one too, 534 versus like 592, and on the left these values are lower, and it got still got quite a few wrong, but just things to keep in mind. So then on this logistic regression, even more interesting, because now this one really favored predicting the price would go up. that made very few predictions that the price would go down. And you might be wondering, okay, so this is great, but if you actually had good results, how would you know? And I think that, in all honesty, to really tell, you'll probably have to look a little bit at these precision recall scores, F1. So when I cover them in a future video, we'll explain that better. But just looking at the confusion matrix, you would generally see more values on this forward diagonal than on the backward diagonal. We also have to account for how many values, or what the division of your categories are in your data set. So for example, if Apple had more price increases than decreases, say it had 60% price increases and 40% price decreases in the data set, then in reality we would have to factor that into our thinking. So we would expect that it would disproportionately favor price increases if our data set favored price increases. But again, I would just be looking at proportionately more values on this forward diagonal than backward diagonal, which we have not seen yet. So far it's been pretty even. You see like 6182 and 997, 930. Like I said, basically just guessing. So moving on to neural network. Yeah, neural network similarly favors price increase. And SVM is similar to KNN. It still looks like it's just guessing. Again, I can't say I'm surprised. But hey, I mean, this is the basic foundation on how you could perform your own stock analysis with AI. And you can do some really cool things like sentiment analysis and tie it in with the pricing data or return data to see if you can do something better. And I think maybe in the future we'll do that. I know I'm definitely going to do a sentiment analysis video, but let me know in the comments if you want me to try to tie it into stock price prediction or anything else you want to see. So I'm going to end the video here. I won't do the prediction step like I did in the last video. It will be the same. Essentially, you would just have to recreate these 4 blocks with your prediction data, and then feed it to this the prediction block in evaluate. Here it is in predictions. But I did in the last video. I'm not going to cover it here. Just let me know if you in the comments if you want me to do it, and I'll happily do another video with that in mind. Thanks for watching.